The Pythagorean theorem states that if ABC is a right triangle at E, then we have BC squared is equal to AB squared plus AC squared. Now the question is the converse true? Meaning that if we have a triangle with this equality, BC squared equals AB squared plus AC squared, is this triangle right at E? Now let's prove the converse of the Pythagorean theorem. Here we have a triangle ABC with AB squared plus AC squared is equal to BC squared, and we want to prove that this angle here E is equal to 90 degrees. So how we will proceed? Here the first thing is we construct the triangle A'B'C' such that A'B' is equal to AB and A'C' is equal to AC, but this angle here is right. This construction is possible. We have AC and we have AB. And now we will prove that those two triangles are congruent. And since this triangle is right, we use the Pythagorean theorem, the forward direction. So here we have B'C' is equal to squared is equal to A'B' squared plus A'C' squared. But A'B' squared is just AB squared. And A'C' squared is AC squared. And here you see B'C' squared is equal to AB squared plus AC squared. But AB squared plus AC squared is equal to BC squared. From our assumption. Now we see that B'C' squared is equal to BC squared. And since the two numbers are positive numbers, that means that B'C' is equal to BC. So here B'C' is equal to BC. Now let's look at the two triangles A'B'C' and ABC. We have A'B' equals AB. This side is equal to this side. And A'C' equals AC. This side is equal to this side. And also B'C' equals BC. This side is also equal to this side. Meaning that our two triangles are congruent. And when two triangles are congruent, that means that also their angles are equal. So since this angle is right, this angle also must be right. So we have our angle here, E, is equal to 90 degrees. And this of course means that the triangle ABC is right at E. This of course concludes our theorem.